Let's talk about null pointer exceptions. If you've been a developer for any amount of time, you've had to deal with null pointer exceptions in your code. Whether you're a complete newbie or if you have decades of experience, at some point you'll end up with null pointer exceptions and the nasty stack traces that result. It's simply part of the process of developing code. Of course, finding null pointer exceptions during development instead of once your code reaches production is the goal. Let's spend a few minutes and talk about what a null pointer exception is, what can cause it, how you can detect it or better yet, prevent it, and what are the implications of null pointer exceptions from an application security point of view. So first, what is a null pointer exception? In the Java programming language, the literal, reserved word, null, indicates that an object variable currently refers to no object. In Java, an object variable contains a reference to an object that's stored elsewhere. When elsewhere is nowhere, that's what null is. All Java objects exist on the heap. When an object contains another object variable, it contains a pointer to another object on the heap. Should your code reference an uninitialized object, rather than giving you back some random piece of memory, like in the C or C++ language, the Java runtime will generate a runtime exception, the null pointer exception. This gives you the opportunity to do something resourceful in your code, like respond to that event and to keep going to get to a recoverable state. Although it may not seem like it, getting a null pointer exception in your code is a good thing since you can take appropriate action, like logging the event, clearing the condition and trying again, or simply complaining to your user about their bad data. In other languages, you might continue on, unaware that you've accessed the wrong data, and end up corrupting the memory in your application. Java simply won't let you do this, so you'll never end up with a segmentation violation and spend hours debugging a core file. Let's examine the process of creating an object variable in Java. First, we'll define an object variable called var01 of type string builder. What we're saying in this statement is that the object variable var01 can refer to objects of type string builder. Looking at it graphically, the green rectangle represents the variable var01, and it contains a pointer to, or a reference, represented by the blue arrow, to something. Since we didn't initialize the object variable, it refers to nothing, which we represent by the red circle with a line through it. By the way, this symbol has a name, and it's called the general prohibition sign. Yes, I did have to look this up, so now we both know. By default in Java, object variables have a default value of null when they're not initialized. So is there anything wrong with what we've done so far? Not at all. This is perfectly reasonable code, and no harm will come to you so far. No harm, that is, until you try to invoke a method on the reference that is pointing to nothing. In the next example, we explicitly set var01 to null, really no different than what we saw in the first slide. We know that var01 points to nothing in memory. But if we invoke any methods on the var01 object variable, it will attempt to invoke those methods on the object that it refers to. So let's say that we want to print out the length of the contents of var01 using the length method. Because there's no object that we're referring to, a null pointer exception will be thrown. This is a runtime exception or unchecked exception, meaning we don't need to specifically provide a handler for it at compile time. So if no handler is provided, our application will crash. Notice there's one bit of odd behavior regarding object references that turns out to not be that odd after all. If we print out the object reference without invoking any methods, we get the string null printed, and we don't get a null pointer exception. You may have seen this in your own code and wondered why it didn't crash as you might expect. The reason is in the library that was invoked to print the value of the object reference, it checks the value of null before printing out its contents. If the variable is null, it simply returns the string null rather than the reserved word null, and without referencing the uninitialized variable, and thus preventing a null pointer exception. Now let's initialize our object variable by use of the new keyword and set it equal to an object type of string builder. In the constructor, we'll pass in the message hello world. Graphically, we see that now var01 refers to an object which we represent by an orange rectangle containing the string hello world. We can create another string builder object variable, var02, and set it equal to an object of type string builder that we initialize with the message Happy Friday. Notice that var01 and var02 are completely different object variables pointing to two different objects. If we define a new object variable, var03, we can set it equal to var02 so that now var02 and var03 both reference the same object. Now that we know a little more about what causes null pointer exceptions, how can we fix, or better yet, prevent them? There are several ways, but we'll list a few of the most common. Let's assume that we have a string builder object variable, var01, set equal to null. How can we prevent this from throwing an exception when referenced? First, we can use the ternary operator to check the value before we access it. Here, we compare var01 to null. If it is null, we return an empty string, otherwise, we return the contents of var01. Returning an empty string won't always be the right answer for your application and will depend on the object reference type that you're checking, but in general, the pattern will serve you well. Next, you can simply have a conventional if-then-else ladder and check if the value is null, and simply return back to the caller if it is. Next, you can use one of the null check methods from the objects class that was introduced in Java 7 and updated in Java 8. Here we see that the require non-null method simply checks to see if the value is null before use. If it is null, an exception is thrown. A simple way to address this problem is to initialize the object variable with a reasonable default value. In our example, we assign an empty string. Finally, we can use the try-catch block to deal with handling runtime exceptions. They provide a simple way to deal with exceptions. Depending on your application, the framework you employ may have global error handling capabilities that we can use as well. Finally, let's look at null pointers and the security implications they introduce. Null pointers are a reliability concern, and they affect the availability of your application code. This simply means that if your application can't handle bad data, whether it comes from a bad actor or from bad data that you didn't properly sanitize before use, it can cause your application to crash and not be available to your users. This can do a couple of things. First, it can cost your business money. Most companies are in the money-taking business. If your application keeps crashing, it can't get the money that your customers are trying to give you. Next, if your customers can't access your app, they'll tell their friends on social media and their business associates, and your business will suffer until you get your code fixed. Believe me, as a developer, you don't want to be responsible for either of these problems. Next, your application may not always crash if you're able to catch a null pointer exception. Sometimes the applications will catch the exception properly, but then leak the stack trace outside of the bounds of the application, such as sending it to a client that invokes an API call, rendering on a web page, or displaying it to the console where an administrator may see it. The only safe place to write a stack trace is to a log file or other persistent store that only authorized personnel or processes are able to access. However, problems may still arise in your application if it ends up bypassing some logic that properly sets access rights or other restrictions and ends up giving the user some kind of default access that is greater than what they're entitled to. Your application should always default to no access and fail closed. Granting admin rights or full CRUD access is a disaster waiting to happen. Alright, that wraps up our look at null pointer exceptions. If you like this video, please give it a thumbs up and consider subscribing to this channel where we'll be sharing more information like this in the future. Take care and make it a productive day.